Okay, so hey everybody, we should be, or you should be seeing my second screen here, which is my VM, and I've logged into Buffet and selected our 8510-students repo and did a copy of the public URL. And I wanted to make sure that I have the latest Git repo code on this system. And so I won't do this again because I just did this a couple minutes ago. Issue git clone and then do a paste of what you copied, and that'll place the URL in the right place, and you'll be able to obtain a local copy of the repo. And as you've all seen, so in the past, there's a number of directories. We're going to go into NS3. Okay, so there's two directories containing NS3 code that we're going to look at, and then there's a CC right-in that'll be placed right in Scratch in the NS3 directory Scratch called mycommand-line-example, and we'll be running that. So there's three scripts that we're going to run in NS3. Okay, so if I do a go NS3, I've got that alias set up to place me at the top or the home directory of NS3. And so from here, we see a whole bunch of directories. The most interesting one is going to be Scratch. So that's basically our work directory. We place stuff in there that we want to work on. So I'll go back. Oops. There is also a script that's provided in our repo in the NS3 directory called clemsonns3.sh, and this is a bash script meant to sort of give you something to work with to help you automate running NS3. So just to give you a quick overview here, when you run this script with no parameters, it's going to show you a help screen, which is probably a little bit out of date. Then it takes a single parameter, like a 1, 2, 3, 4, and it will run NS3 in various ways. So if I do Clemson NS3, that looks roughly correct. Okay, so as an example, let's run by hand the ran-vars script, and we'll step into it and talk about it shortly. But to run it, do it this way. I don't even need the parentheses. Scratch ran-vars, where ran-vars is random variables. Okay, so everything, when you run NS3, what I usually do is I always indicate Scratch, then / if The .cc is located right in Scratch. I would just need to name that .cc minus the .cc. But ran-vars, the cc is in a subdirectory called ran-vars, and so that's why we call it in this way. Notice the output. So in overview, this program is super simple. It creates a uniform random number generator, an exponential random number generator, and it also has code that illustrates how to set up event handlers. Okay, so let's look at, and by the way, we run this and give it a parameter of 1, it should do exactly what we just did. Okay, so go into Scratch, go into ran-vars. All right, so there's a single CC file. So basically this CC file is a script, and it will build the simulation model for us. A script that builds a model has some common things. So there's always going to be a bunch of NS3 include files. If it's something I create, I always have a header that tries to document what this program does, because this NS3 script file is the program. So it has to have a main clause in it. So this program will take one optional parameter, and it's meant to specify the mean of a random variable and of the exponential random variable. There's an internal variable called with_command, and so this is one of the common themes in all of the examples that we'll be looking at in this video. There's the NS3 supports command line arguments, just like a regular program, or it also has this very sophisticated method of allowing you, when you invoke the script, when you run the program, to specify not just program arguments, but to set internal variables within the script. And the way NS3 does that, it's called program options, and we'll see how to do that in a different example that we'll look at. This example does not do that. It we're going to set with command just an internal variable to 0 because we want to obtain arguments the old-fashioned way. All right, so we are creating some handlers, event handlers. And again, this is more for illustration purposes. A common method that's required in a script would be the start method. And here's an example of a event handler. Okay, and probably through the illustration of calling an event, we're going to be somehow calling this function. And then finally, we get to main. Okay, logging is a big topic on its own. We'll go into that at a different time. Actually, I think Manveen might have talked about it. So in our little program here, we declare a variable called mean value. And set it to a default of 2, we get current time, so simulator time. We're going to log, in a log file, we should be able to see something called ran-vars. And so we have not defined with underscore command. So we're going to, sorry, this pound if is actually looking at the value of that variable. So if that's true, we're going to do the more complex options handling, and that is using an object in NS3 called command-line. And we'll talk about that in a different example. So here we're pulling our single argument, if we have it, into mean value. So the NS3 exponential random number generator has 2 parameters. It has the mean, the desired mean, and we also will give it a maximum value that we ever want it to produce. We will set the seed. So we talked about with a random number generator, the seed, sort of like the index to the set of numbers that the random number generator, if it's an algorithm, will cycle through. And we talked about if it's full period, which is a desirable attribute of a random number generator, that means that the random number generator is going to go through all of possible numbers that it's capable of producing, and that is a full period. So we set our seed, looks like we just randomly set it to hex 15. This is an example of creating a variable X and its type pointer, capital P, TR, uniform random variable. So putting this into sort of a C context, it's going to be a pointer to an object of type uniform random variable. NS3 supports smart pointers, and that's what this format is. And we'll talk about that later as well. So this is the NS3 sort of global object maker. It's going to create a uniform random variable object, and X is going to be effectively the pointer to the object. We could look up on the NS3 documentation to find all of the methods available with a uniform random variable. So let's go ahead and do that. Let's see, NS3 uniform random variable. Okay, and so usually we want the class reference. Okay, so member functions include, if we wanted an integer, and we could specify the interval. So the minimum and maximum, we want a random number that is in between, inclusive of the min and max, and an integer. Get integer with no parameters is probably going to be a uniform, so it's between 0 and 1. Get value, which is what we use in this code. We give specify the min and max as a double, and we get in a random variate, a random number in a double format. So GetValue is what we've called, and so we're asking for a uniform random number in the interval 0 to 10, and that is being placed in our variable called myRandomNumber. And so we print that. And then just to illustrate how to schedule an event in NS3. So it's as simple as using the global variable, actually the global object simulator, and then the method schedule. And again, we could look at the documentation and look up scheduler simulator, and we would see all of the methods that goes with that. So let's try to do that. NS3 and simulator. That may not give me what I want. Simulator, I'll say schedule. Okay, so talks about it in this particular tutorial, but I want the class reference. So we're going to look at the member functions for what? For simulator. Okay, so this is the simulator object, and these are all the methods. Destroy, get context, get event count, and I'm looking for schedule. So schedule and events. Okay, that's not quite what I wanted. Simulator. Okay, there it is. So the schedule method, we provide the time. So that's the time in the future, simulation time at which we want this event to run or to execute. All right, and so in 10 seconds, example function is going to run, and it's going to pass this reference as a function. Then we schedule the random function to run at the random time in the future that we obtain from the uniform random number generator. Okay. And this is a way, there's a way of identifying an event and canceling it if you wanted to. This is now going to create an exponential random variable. And as I said, there's two parameters associated with it. So y is the random variable, and we'll set the two parameters with the set attribute method, the mean and the bound. And here is an example of how we're going to get a sample. So we're obtaining a random variate, putting it in my EXP random number. And another method is get mean. So my EXP mean should be exactly what we set. before with the parameter mean value. And that's pretty much it. So the next example to look at is exercise 3, which was posted. So this is what you should have looked at and attempted. I believe I have pretty much close to a solution here. So we'll take a quick look at this. So exercise 3.cc. Okay, so it builds on ran-var that we just went through, but it's a little bit more interesting. So what this program does, it's sort of a boring simulation. It's really just a program that is going to exercise the random number generator of NS3. It's going to produce a bunch of random numbers, okay? And so in addition to the desired mean of the exponential random variable, two other parameters are, call it X and Y, okay? So X, iterations, and Y, samples. So iterations, when we do an experiment, we typically do multiple runs, and we set a seed, a different seed. So, and in fact, most random number generators not only let you set the seed, but they divide the number stream available by the random number generator, which typically is huge, into sections or segments. It's called different things, but what this script or program is going to do is, for each iteration, we're going to move to a different random number generator segment. Okay, so basically it will give us a completely new set of random numbers for the next iteration. So iterations are, the idea is we want a new evolution of randomness. We want our model to run with multiple times. Each time it has a different random path, and this allows us to then take the average, and so we'll see in 30 seconds here a bit more clearly what I'm talking about. So we're going to do a number of iterations. Each iteration, we're going to generate Y samples. In other words, Y number of random numbers. Okay, and so the example I'm going to use is we're going to do 200 iterations. Each iteration will produce 2,000 random variables or random variates. After the 2,000 samples are obtained, we compute the average, and then we put into an output file sample means.dat the timestamp and the average of all 2,000 random numbers. So at the end of this simulation, we're going to have sample means.dat will have 200 lines, one line for every iteration. Each line is the average of 2,000 random number generators. Okay, and so if you remember the discussion relating this to Stats 101, so those, the average of each iteration, if we were to plot the probability distribution of that data set, so those 200 numbers, we would see a something that actually looks like a Gaussian distribution, because the law of large numbers and the nature of statistics allows us to, well, tells us that, and we'll later show how we use that to be able to obtain statistical results from the simulation that have a level of confidence associated with it. So at a high level, that's what this simulation is doing. And it's very straightforward. So I'm not going to spend any more time looking at this. We'll just run it. All right, so I'm going to run it. Using, I could just say Clemson NS3.sh and specify 3, because that's what I want to run, but I'm going to type it out. So that looks like a typo. Scratch. I don't have an example. So I'm going to do history, searching for prior calls to WAF. Okay, so I don't have an example of this, so I'm going to wing it here. WAF-v-run scratch ex3 parameters. All right, first parameter is the mean. We'll say 50. Second parameter is number of iterations, 200. And third parameter is number of samples per iteration. We'll say 2,000. And I hope this is right. Okay, it was right. So what this produced for us was the data file sample means.dat. Okay, and so the first field is the timestamp. The second field is the random numbers substream. So each iteration we change streams. Then this is the iteration number. So we should have 200 entries in this file. And this is the number of samples. And this is the average of the 2,000 random number samples. Okay, I'm going to start MATLAB. This will take a few minutes to come up. Basically, in MATLAB, we're going to plot the distribution associated with the this last field. So there'll be 200 data points that we plot. In the latest Git repo, so in addition to the NS3 material, I have updates to what's in MATLAB. And so this should actually be all set up for us to run. So the sample means.dat that is here was actually produced. I produced this the other day. It's the output of running EX3. So to speed things up here, let's see. So I copied the MATLAB updates to we're now looking at my host machine. That's where I'm running MATLAB. Okay, and so plot data PDF should be all set. It's going to load sample means.dat, and it should give us a figure. Okay, so this is the distribution of, okay, this is mislabeled PDF delay samples. So it's really the PDF of the average random numbers for each iteration. So there's 200 data points here. And again, the theory states that this distribution, the mean of this distribution is the true mean of the exponential random number, and everything that is plus or minus forms a normal distribution about the true mean. Okay. So now, last example to look at is this CC file, this script called mycommand-line-example. So this has nothing to do with random numbers, but this is going to illustrate the command line object capability in NS3. So NS3 comes with lots of examples, right? So if you go to the main NS3 directory, there's a subdirectory called examples, and there's even more examples than what are in that subdirectory. So if you go to source core doc examples, you would find command line example. So this is a example that comes with NS3. I didn't change it significantly. So this is indicating correct ways to run the script, to run with a parameter. This is an incorrect way to run. So the syntax for this script is program options, program arguments, general arguments. So general arguments are what we used last time in the last example, just traditional program arguments. Program options is what we want to demonstrate here. So this script, this program, is going to use this set of options. Okay, and so the way to decipher this is --int arg needs to map to a variable in the CC file in this program called int arg. And so, and similar, string arg, bool arg, these need to be the actual names of variables of the correct type. So when we run this program, this illustrates how we use the program options. So when we do --int arg equal 2, str arg equals silly, --cbr arg equals world, the internal variables are going to be set to these values. Okay. So I'm going to do waf -v--run scratch my command line example program option arg equal 2, so set it to 2, and I'm just setting this, we could set it to any number, right? Set the string arg to that string, and then this cb arg is it's actually going to be used, the code illustrates firing an event and passing that argument. CBARG equal world, end quote. And let's hope this works. Okay, whew, it works. This is what you should see. So if we were to look at the code, we see it's going to display the initial state of the variables. Then it's going to show the state of the variables after the options have been processed. So notice int arg is 2, bool arg is false, string arg is silly. Okay, that's it for this video, and thank you for watching.